If you watch my videos, then you know that I love Python. It's one of my favorite programming languages, I use it all the time, and I have literally hundreds of hours of content teaching it on this channel. With that said though, I'll be the first to admit that there's a lot of issues with Python. It's notoriously slow, it suffers from the global interpreter lock, and that means that a lot of programmers start out learning Python and then move on to some more capable languages like C++, Go, Rust, Java, etc. They might not want to do that, they might love the syntax of Python, but they have to due to a lot of its limitations. Now, fortunately for all of us Python users, there may be a solution coming very quickly called Mojo. Now, Mojo is a new programming language designed by a company called Modular. It's not even available yet, you can't even download the compiler, but from what it's promising on its website and the limited documentation that I've read, it seems like it can be a great solution for anyone who wants to use Python but get the performance of a language like C, C++, or Rust. In fact, Mojo even claims to be 35,000 times faster than Python, and if that's even remotely true, then this is going to be a pretty big deal. So with that said, let's have a look at Mojo and just go through some of the features that it's promising after I share with you another really cool tool that's going to rapidly speed up your workflow, which is the sponsor of this video. Docker. Docker is a suite of software development tools for creating, sharing, and running containers and can dramatically accelerate and simplify your workflow. For millions of developers, Docker is the de facto standard to build and share containerized apps from the desktop to the cloud. Now, fortunately, it's got even easier to work with Docker with their new release of Docker Init. The new Docker Init CLI generates assets for your projects, making it even easier and faster to create Docker images and containers. Running Docker Init walks you through the entire creation of necessary files with sensible defaults. These files include Dockerfile, .dockerignore, and dockercompose.yaml. Docker Init simplifies project creation, saves you time and effort, and best of all, is completely free. Now, if you're like me and you value time and speed, this tool is an absolute game changer, and you can download it by just downloading the latest version of Docker Desktop from the link in the description. Not to mention, Docker is also running a giveaway where they're going to be giving away 50 sets of Docker swag. All you have to do to enter that is join my Discord server at discord.gg/TWT. That link will be in the description as well. Thanks again to Docker for sponsoring this video. Now let's get into it. So let's start with what we know about Mojo. First of all, this is aiming to be a superset of Python. That means that all of the Python features you know and love, eventually you'll be able to use directly inside of the Mojo language. That also means that Mojo will provide additional features that you can use that should speed up the execution of your program and allow for things like strong type checking. So think TypeScript for JavaScript. That's kind of how Mojo is positioning itself, except it's promising massive benefits in terms of speed. So if I scroll through the website here, Mojo is really focused on AI and systems level developers where what you need is actually raw performance. You're trying to manipulate maybe memory or some lower level features that you don't typically have access to in Python, and by doing that, you're able to speed up the compilation and interpretation of your code. So I'll just scroll through some of the main points that they have here. First of all, usability and programming. Write everything in one language, so write Python or Scale all the way down to the metal. Program the multitude of low-level AI hardware, no C++ or CUDA required. So it goes through a few of the different features it has here. I'm sure to many of you this means nothing, but for people that are low-level developers that typically would have to write libraries in C++, Mojo can be a pretty big deal, allowing you now to do this in Python and use these additional features to get closer to the metal. Continuing, unlock Python performance, so utilize the full power of hardware, including multiple process cores, vector units, etc. So the basic example here pretty much illustrates this. In your standard Python programming language, you have a global interpreter lock, meaning even if you have a multi-threaded application, it's only going to run on one CPU core at a time, really limiting its performance. With Mojo, that's not an issue. You have access to multi-threaded and parallel processing, which means you can actually run your different threads on multiple CPU cores at the same time. Continuing, Mojo is promising up to 35,000 times faster execution times than native Python. Obviously, I can't verify this. This is just what they have on the website, and I'm sure this is only the case for very specific tasks. However, you get the idea here. It's kind of giving the comparison with the different compilers, languages, etc. Now, one of the great things about Mojo, at least again, according to their website, is that you will be able to import any existing Python libraries or modules. That means that anything you would have used in Python, say like the NumPy package, you can just import directly inside of your Mojo code and use it just like it was normal Python. Going through here, there's a bunch of other stuff that's kind of focused on AI. I won't get into that right now. And just as a reminder to you, this is not currently available, right? You can't download the compiler and mess with it. What you can do is go into this playground that I just got access to and kind of run your code in a Jupyter notebook, which we'll do in just a second. So we're going to dive into that notebook in a minute, but I just want to give you a high-level overview of some of the problems with Python. So Python obviously has this global interpreter lock. What that really means is that if you have a multi-threaded program where you've split your program up into different pieces that can be executing independently, since we have this lock, only one of these threads can execute at a time. Now, there's a way to get by that using something known as multiprocessing, but this becomes much more complicated and gives you all kinds of problems when it comes to accessing shared memory and resources that I don't want to dive into here. So first of all, Mojo essentially removes that global interpreter lock with the compiler and interpreter that it uses. Again, we don't need to dive into the weeds there. The next problem with Python is that although it does provide a lot of bindings for C and C++ code, this means that if you want to write any performant application in Python, what you're really doing is writing some C or C++ code, building some kind of wrapper around that, and then importing that or using that from Python. Now, this can make it extremely complicated to debug that code, to find the errors that are occurring, and just to write that code in the first place. Now, all of a sudden, you want to do something very performant in Python, like systems programming, and you need to go and become a C++ developer, and then learn all of the intricacies between the different Python compilers, and how you're going to actually be kind of injecting or importing this code into Python. Very, very high-level overview. It might not be entirely accurate, but you get the point here. If I want to do something performant, now I'm outside of the Python ecosystem, I'm learning something like C or C++, and that's probably not the best use of my time or something I really want to be doing if all I'm trying to do is just squeeze performance out of this language. Now, there's various other problems with Python as well, a lot of them coming from how Python code is compiled and interpreted, and the fact that Python is a dynamically typed language, meaning there's a lot of inferences that cannot be made during the compilation phase of your Python code, which really reduces the performance. So again, Mojo is aiming to solve most of these problems with this new superset of Python. All right, so I've just jumped into the Mojo playground here, and we'll have a look at some of the features that it's promising, and you can kind of see the advantages of this language. By the way, I'm not at all endorsing Mojo. I've not been paid by them or contacted by them. I just wanted to talk to you about this language and see what you guys thought, so let me know in the comments down below. So first of all, a cool thing about Mojo is that the file extension for Mojo can actually be this fire emoji. You heard me right, you can literally do like pi or script dot and then this fire emoji, or you can use .mojo. So I thought that was kind of an interesting feature. When you're going to be compiling or running your Mojo code, you use the Mojo compiler, which doesn't yet exist, where you're typing Mojo and then whatever the name is. Okay. So going through here, you can see that just like in regular Python, we can print hello world, or in this case, hello Mojo, and that's going to work entirely fine. Now, the first feature that Mojo is adding here is something known as let and var declarations. Now, if you're familiar with Java, JavaScript, etc., you may have seen these before. They're actually not necessarily intuitive compared to something like JavaScript, but they allow you to define constants or immutable values as well as mutable values. So if you use the let, this is actually going to define an immutable value, and if you define a var, this is going to be mutable. So if we have a look down here, you can see that if I define my variable c using this let declaration, it now is immutable, meaning if I tried to do this, it's not going to work. It's going to tell me this is immutable and I can't change it. So actually a useful feature that currently does not exist inside of Python without using some pretty complicated classes and kind of properties and all these things that I'm not going to discuss. So you can do that. Now, you can also just define a regular variable, right? So if I just say, actually not a equals 2, let's go like x equals 6, this would be perfectly valid. I'm now just using the dynamically declared variable from Python. Coming down here, we have the ability to do things like late initialization, which again, we can't do in Python. So I can initialize a variable, define the type of that variable. This would be int, this would be float64, float32, etc. And then later on, I can initialize that value. Continuing, Go has structs. Now, structs are similar to classes, but they work a little bit different when it comes to performance and the way that they're created and handled. And if you're familiar with C++ or Go, you've probably seen these before. Now, a struct is statically initialized, which means that you cannot add instance methods or properties to it during runtime. So in Python, if I create a class, I can go ahead and add a property, I can add an attribute, I can add another method, I can do all kinds of very weird and dynamic changes. With structs, I can't do that. However, in a lot of cases, that's what you want, and this allows the compiler to actually make a ton of inferences about the code, which allows you during interpretation to speed up the code execution quite significantly. Essentially, when you use a struct, what you're doing is trading flexibility for performance and speed. So if we go through here, there's a bunch of kind of different features of the struct. So first of all, we need to declare all of the instance methods we want to have. So I declare those as mutable values using var, and I have to declare those right away. So again, I can't declare those during runtime. I have to declare them before, or I guess during compile time. Now, another cool features of our structs is just like in Python, we can overload different methods. So here I can overload my LT, which is less than, and then implement that less than operation on this struct type. Now notice here that we're using fn instead of def. Now this is a new type of function that you can define inside of Mojo that has some performance optimizations to it and allows you to define the different values or types of the different parameters that you have. So in this case, I'm using in-out. What that actually means is I have a mutable parameter here where I can modify what's being passed in. There's another thing which is called borrow. If I use borrow, that allows me to define this as an immutable parameter. Again, we don't need to dive into it, but you can kind of see some of the flexibility that's being provided here. Continuing, we also have strong type checking. If you know what that is, great. If you don't, I'm not going to explain all of that. Continuing, we have overloaded functions and methods. So this is actually quite cool and something that you can typically do in like C++, or Java, etc., but that you can't currently do in Python. So here I've actually defined two versions of the init constructor, one version that takes an additional parameter here, takes actually different parameters here, r and I, where this one only takes x. That means that based on how I call the constructor of this complex struct, I'll actually enter into a different function or a different method here based on the one that I called. So quite useful thing that's being added. Next, we have these fn definitions, which as we've kind of seen are new ways to define functions that differ from def. Now, first of all, def and fn are always interchangeable from an interface level. That means that I can change a function to use fn or def, and that doesn't affect the behavior or the way in which I would call this function. So if I'm viewing some function, I don't need to know if it's defined with fn or def. I just call it how I would call any other function. That's good to know, but there is a few important changes here or differences between the functions. Now I'm just going to actually read from my notes here because I don't want to mess this up. So one of these changes is the following: all values passed into a Mojo function use value semantics by default compared to Python. This is an important difference as a Mojo function receives a copy of all arguments. It can modify those arguments inside of the function, but those changes are not visible outside of the function. That's the default with an fn function. Whereas in Python, when you have a def function, if I pass a mutable argument to the function, I can mutate the value of that argument and it will be seen and affected outside of the function. This is something I've talked about in quite a few videos and is a mistake that quite a lot of beginner Python programmers make. So in Mojo, it disables that behavior by default, and you have to explicitly enable that, which allows you to avoid a lot of errors that you might typically have. Now that leads me into the last part of this video where I'm just going to quickly share with you my thoughts about this language. So first of all, this is extremely early. If everything they're saying is true, then this is really cool. This is a powerful language. I'm definitely going to check it out, and I'd probably do a tutorial series on it. However, it's really too early for us to know. I have no idea if this is going to live up to all of the expectations, if this is going to be as good as it says it actually is, and if this is going to be something that even really matters for your typical Python developers. It seems like they're really positioning themselves here for AI developers, for low-level programmers, not for your typical Python devs, and that might mean for you and me, who don't do that every single day, that Mojo isn't really something that we need to learn or something we need to be concerned about. We can just keep going about our day using typical Python and not worry about this. However, maybe a lot of people will be using Mojo, it'll become more popular, and then it'll be something that you're kind of just expected to learn. I have no idea, but I just wanted to make this video to introduce this to you in case you haven't heard of it yet, and give you the opportunity to check it out for yourself before it's released and before it becomes kind of a big hype thing, which I think is a potential. Regardless, I hope you guys enjoyed this video. If you did, leave a like, subscribe to the channel, and I will see you in the next one.